So my name is Nir Rosenfeld, and I am the CEO of Cyber 2.0. Today's webinar is going to be very, very interesting, and let me tell you a story. Well, last Friday was very, very interesting for us. We wake up in the morning, and our customers started calling us, and they're telling us that they have problems with their computers and they need help. And we started to try and assist our customers because at the moment nobody knew what happened because everybody was getting blue screens and we couldn't understand what's going on. And eventually it got published and everybody understood that it was the CrowdStrike agent and update that caused all those fuss. And it got us thinking. It got us thinking all over the weekend, and I think everybody's been thinking about it. What happens when the EDR system, when your defense system turns back on you? What happens when you install a defense system and that defense system basically is going backwards? And instead of protecting you, it's not just protecting you, but it's making a fuss. Now in the last 3 weeks, we've been making webinars about if you keep doing the same things, you will always get the same results. We spoke about the philosophy, what's going on in the cyber world, what's going on in various places, what's going on in attacks, how hackers think, how the AI tools started coming into our life and how they made it easier for hackers to start attacking. I've been speaking about it in podiums, in webinars, in a conference last week. I also spoke about it, and I told everyone, if you keep doing the same things, you will always get the same results. We must start adopting new ways of thinking and new ways of technology, and we always have to do it. And then after what happened last Friday with CrowdStrike, we also started thinking again, what happens? We need to think about it differently because I don't know how many of you managed to see the interview with CrowdStrike that was published, but there were difficult questions that he was asked there. And I don't envy him for getting such questions. But how can we, as a defense company, how can we as cyber people can protect ourselves from the unknown, from our defense systems? Now, we made a lot of meetings, me and my vice president, Mr. Guy Tesler, VP, Vice President of Business in the United States, Ms. Yana Hefer, my VP Sales in Israel, my CTO, Mr. Erez Kaplan, and we spoke about it a lot. The COO, Tanya Sarel as well, we spoke about it. We started negotiating what can we do. And then Erez was not worried about it, and we started explaining what he thought 5 years ago. Now, that's amazing because, again, one of the things that drives us as a company is always thinking to do it differently. What can we do that nobody else did until today? How can we do it different? How can we do it better? How can we do it faster? How can we do it more secure? If you keep doing the same things, you will always get the same results, and we want to change the results all the time. And we must look at it in a very, very interesting perspective, not just as something that happened to CrowdStrike, but something that changed the world. There have been malfunctions in updates before. They are not the first one that it happened to them, but this was on a huge scale, And we need to start thinking about the defense systems that we have. Should we have just one defense system or should we have many defense systems? How can we protect ourselves better, not just from the new attacks that are coming and they will be coming because the AI got so much things going on for the hackers and made life easier for the hackers, but how can we do it and still protect ourselves? The presentation will be said by Mr. Erez Kaplan, the CTO of Cyber 2.0. Erez is a long friend of mine, and I'm very, very happy and proud to meet him here. Erez will be talking about development. He will talk about the CrowdStrike incident, and he will give us a brief about what happened and how things reacted and what are the dangers in it. And he will speak about development and other things. And of course, how can we better protect ourselves in other ways when our EDR system fails? How can we still protect ourselves? Because one of the huge problems that we saw is once they got over the blue screen and they were able to turn on their computers, they still had a huge problem because they went up and the CrowdStrike agent was down. So they went up with no defenses, and this is what we need to start thinking about. How can we do that extra layer of defense? How can we continue protecting ourselves? Erez, where are you?
Hello, everyone. Can you wait? Hello, everyone. Pleasure meeting you all. There is a loop from someone. Okay, close that. Okay, loopback ended. Hello, everyone. Pleasure meeting and seeing you all. As Nir said, I will bring you up on what happened precisely with CrowdStrike, what are the results, what are the conclusion, and what we can do to avoid such a thing, and what were the major problem, and how Cyber 2.0 deals with them. Without further ado, let me share my screen with you. Let's start with it. Excellent. All right. It was same. Let's start just a second. Excuse me, let me fix the issue with my computer because everything was working. Just 1 second, my PowerPoint seems not to want me to open in presentation mode. Let me fix it.
One of the things that happened when we started and we saw that everything mucked up in the CrowdStrike incident was we had huge meetings here. We were speaking with our partners, our colleagues, and our friends to understand what's going on, and it was very, very interesting because we saw that there were people that were still harassed by this solution 3 days later. Erez, I see that you managed to stop your site
Yes,
attack, so go for it.
there was something stuck at the PowerPoint. I disabled it and restarted it. Sorry for this, we tested it before, but let me start without further ado. When your defense system strikes, let's see what precisely happened. Millions of Windows-based PC simply seem to have crashed. In one single instance, a patch was released, and everything that was connected to CrowdStrike defenses simply crashed. No one knew what happened at the beginning. There was tremendous amount of chaos because no one was sure. We've got multiple phones from multiple clients asking what has happened, if we know if there is a cyber attack. And at the beginning, everyone thought it was a cyber attack because there was no flight, no banks. Money cannot be taken from the banks. Even supermarkets fail and you had to pay with cash, but you can't take out cash because basically everything became a mess. And in Israel, at least everyone at the beginning thought it's a cyber attack. Then suddenly everyone noticed that it is something which is globally wide. It took several hours before people started to understand what is happening. One of the major issues in such an event that you don't know where to put the finger. The computer reboots in an endless loop. No one is telling you why he is rebooting. You start to search for Google, but your computer itself crashes, so you try to do it from your phone. Basically, it took time until people understand that this was not a cyber attack, that this was caused because our own cybersecurity, something that was developed by CrowdStrike, and let's see what happened precisely. The problem was a patch, a very small patch that was sent to everyone. The patch basically had inside of it a bunch of configuration add-ons, something that changed, but the patch was a driver. Once a driver is implemented, it directly interacts with something called the kernel, which is the heart of the system. And from there, if there is even one single mistake, the system will reboot itself to protect itself, to protect its memory, to protect other processes. There is a lot of theory around it. But because the kernel driver was loading every time that the computer loaded, every time the computer crashed. So everyone want to fix it quickly because every system in the world was down, and I wonder what to do. And everyone searched the crash between computers who didn't have the problem. Everyone started helping everyone, and we found how to fix it. The fix was extremely, extremely simple in theory. All you have to do is go to a specific folder inside the computer and delete a file. At the beginning, we renamed the entire folder, then we knew precisely what file after a time to change, because people shared information among themselves, and we found the fix. But the second problem was not that the fix was easy. It's easy to fix it. If you got remote access, everything can be fixed in minutes. But you need to go computer, because the system keeps rebooting randomly, not randomly, every reboot. You can't access it remotely. You can't fix it remotely. And you need to start going computer after computer. And there we had several issues. First of all, a lot of computers that kept rebooting themselves did not have and still don't have SSD drive. It means that it can cause a critical hardware failure. The second thing was that it takes time. Once you go to the computer, you need to boot it in safe mode, enter the drive, do whatever needs to be done, delete it, reboot it, and then the system goes up perfectly. So if you got 100 computers, the estimated average time is 5 minutes per computer. Sometimes it takes more, sometimes it takes less, depending on the speed of the computer. You need to do a specific set of commands, enter safe mode, command, delete the file, 5 minutes per computer. So for 100 computers, it takes an average of 500 minutes, give or take, not considering that you need to move from computer to computer and sometimes building to building, and then you have the servers. So 500 minutes is a long time. But if you've got 1,000 computers, it's becoming 5,000 minutes. And for 10,000 computers, you need an army of people that will go computer after computer after computer. The time that it took to fix such an issue in, let's say, medium organization was days. People haven't slept.
5,000. 5,000.
Sorry?
5,000.
Okay, sorry. So people haven't slept for sometimes 2 to 3 days, multiple teams, in order to make sure that everything is loading and everything is working. But some organization, the more secured one, encountered a bigger problem. Sometimes a lot of programs interact with each other. There are regulations, there are requirements. One of the requirements in a lot of secured and sometimes less secured organization is to implement BitLocker. Now, a lot of people doesn't know that BitLocker also implemented almost automatically with Active Directory if you've got Windows 11 and sometimes patches of Windows 10 in almost every laptop. The BitLocker is simple. It's a defense mechanism that's designed to prevent data from being stolen if someone stole your computer. There's a lot of other merits, but that was the main issue here. From the perspective of the computer, he was stolen. In order to access the computer, you need to put the BitLocker code. In companies that they knew the BitLocker code and the BitLocker was stored on a central computer, the central computer itself had the same issue of repeatable booting, but it was a single computer. Once they fix it, they still need to put the BitLocker code, and the 3 or 5 and 10 minutes became 10 to 15 minutes. In some organizations, they didn't have the BitLocker code and they needed to start moving stuff with Microsoft. And in a lot of medium to small organizations, they didn't know that they have BitLocker installed because they installed the Office, they installed the computer, connected it, everything works. But once it enters safe mode, it requires the BitLocker code. So a lot of people had to learn how to access their BitLocker code from the Microsoft website. So a fix that took 3 or 5 minutes, which is extensive because it's per computer, became a major issue in a lot of, let's say, larger and more secure organization, and sometimes even the smaller one, they did not know that they have this issue until it happens. The thing that it does, and we will address it later, a lot of time cybersecurity software interact with each other and interlock with each other to give a better defense mechanism. And one cyber software can crash the entire dominoes of cybersecurity, and we have an issue. Then the problem was fixed eventually. But there is a major but. Protection on this computer gone down the drain. There was no protection. Now, think of organization that it took them a lot of time to fix it manually, then for 2 to 3 days, they had no fix. They had no computer, they had no protection. And no one knows, although now we do know a bit better, what the hacker did during this time. People who rely solely on the idea of CrowdStrike put the server up first so they can do some work, then started working on the desktops. In the meantime, no defense.
אמרתי, זה מאמין, משגע, אבל אני נאלצת לדחות את חיזורך.
Besides maybe a basic firewall that protected the outside, the internal system were without defense. It caused a major issue and people started exploiting it. There were
ארז, תסיר בבקשה, תעצור רגע. תסיר בבקשה את המשתמש, תודה.
As I said, there were multiple hacking attempts, and in order to join them into the fray, a lot of false fixes started to surface. Some of the people were IT, so they know to identify it. Others did not have access to IT, and all the IT were busy helping each other. So a lot of customers found themselves alone trying to fix it. A lot of false websites went up. One of them, for example, gave you a CrowdStrike hotfix zip. The hotfix zip was a ret, allowing remote control over your system. There were at least 50 websites that we are aware of that were false, all of them starting with CrowdStrike, that or the other. We know that hacker has penetrated into multiple network organizations or tried to penetrate into a lot more under the guise of no CrowdStrike and no defense system. And a lot of people installed sometimes fixes that fix the issue, but also installed another thing with it, which is, of course, the malicious software. This is just one of the examples. Sadly, in our world, every time that there is an opening, there is a vile hacker trying to penetrate it, to molest it, especially the fact that it happened into Western countries mainly, and most of the hackers that we get were from other zones. So there was a major outage and attempt to try to penetrate the unprotected network. And since it took days to fix the issue, and only after that they returned the defense system, and a lot of the defenses were vulnerable infrastructure like airplane, like banks, like medical facility, like hospitals, and the list goes on sadly forever in this. There's going to be a lot of hacking attempts or hacking that have been made because of this specific issue. Just to make clear what should be done in this scenario is multiple scan over the network to see what was hidden, what was changed during the blue screen, after the blue screen, before the protection was put. It's to double the work that is already done. Analyzer will have to go on stuff, and we will know the result of this, of what the hacker did during this time. It will take a lot of days to truly identify what has happened and what has penetrated into the network, the unprotected network. And as always, we are not different in this, but we are. Everyone started to say that it cannot happen to them. Every cyber software company that it is said that it can't happen to us. Why? Because we got better QA. Our QA is better. We've got the best QA. We checked everything. We checked every driver. We checked and we check and we check, and it won't happen to us. I truly believe that CrowdStrike also checked and verified, and I truly believe that CrowdStrike has a very good QA, an extensive one. But in the end, eventually, we are humans, and computers are computers. And the smallest mistake that we will make, an oversight of us, can cause, as you see, a major outage. And this thing will happen again. It happened before. There are examples of it happening during the XP, where a patch for McAfee caused a major crisis over the internet. It happened when Microsoft sent patches here and then, but Microsoft tends to minimize it by sending only to the small amount of computer first before generating it to everyone else. So they have a test group, so to speak. But it happens, and the reason it will happen is not just because you have a better QA or a bad QA, because it's not depending on you. Let's say that you have the best QA and the best programmers in the world, and you issue a perfect driver. It's flawless. But then comes a patch from a different hardware vendor, of a printer, of a mouse even, that updates its own driver, and its driver works perfectly also, but it collides with you. Or Microsoft has issued a patch and your driver does not seem to agree with that patch. A crash will happen. A repeatable crash will happen because drivers are always in the kernel. It's enough that someone has changed something. It's out of your control. You cannot test everything because you don't know what will happen. You don't know what patches will be released. You don't know what hardware is installed on the other side. So most of the time, this thing will be small, around 2 to 3 companies, sometimes 100, sometimes 500, and sometimes it can be something that will affect globally, like what we fear today. As I said, it happened before when the internet was smaller. It happened in various occasions here and there. It affects us daily. We simply doesn't notice because usually a patch is sent. Usually the issue is a high CPU, something that's not working correctly on the computer, but a lot of time, it will cause this precisely. This is what everyone feared of, and the best QA in the world cannot save you from that. In order to truly address such an issue, because we know it happened, it's not something in the backdrop that no one knew or suspected, we need to think differently. Currently, everyone is thinking the same thing. QA, better QA, the best QA, doing QA. We are doing it in this way, we are doing it in this way, we have QA. This is basically the only thing that is being tried to do in order to solve such issue or prevent such issue in the further. In order to truly fix it, we need out-of-the-box innovative thinking, because as I said, it will happen always. You cannot avoid it. It can be on a small scale, it can be on a larger scale. I can give you an example. Beside the McAfee and the XP, a long time ago, for example, Microsoft has issued a patch, a major patch to its Windows 10 operating system. The patch worked very good, actually, but once it collided with HP and Dell driver, it caused a blue screen. Luckily, Microsoft only issued this patch into a selected group, as it always does, and they issue also an announcement: if you have HP and Dell, stop installing this patch. And quickly after several days or 2 weeks or something, they issue a patch that fixed the 1807 issue, and it was reverted. But until it happened, a lot of systems, because of a driver of Dell and HP, got repeatable blue screen of that, and the patch was reverted. So in order to truly fix it, the manufacturer of the cybersecurity software, everyone that deals with the driver, need to think differently. Otherwise, we'll all stay in the box, always, and that's not a good thing to stay in the box. So let's speak what Cyber 2.0 has done in order to fix this. As I said, this issue was on the table. It's always on the table. So 5 years ago, we've implemented something that was considered a minor feature in our system. That something is very, very simple. In case of a blue screen that is caused by Cyber 2.0, no matter what the reason is, the next time that the computer will reboot, Cyber 2.0 will disable itself automatically. I will not go into the depths of how this mechanism works, but it's extremely simple, extremely potent, and it's basically designed to fix that specific issue. A feature that was implemented a long time ago makes sure that our client will not suffer from this. Back then, we considered it a minor thing. We thought about preventing such an issue that we witnessed constantly when we did a lot of QA with a lot of other drivers and vendors. We were aware precisely that we cannot prevent it no matter how good and how strong we will check our drivers, because the fault will not be in us, it will be in everything else, and we can cry wolf, it's them, it's them, it's them, but it will happen. So we did it. We put a feature that prevented it, and now that feature becoming extremely important, because our customer, in case that the worst will happen and something will collide, will not be left unprotected. The system will allow them to move forward, will automatically repair itself, remove the affected driver, and will go back up without the affected driver, allowing easily remote control. Everything will work flawlessly, whether it is server, personal computer, BitLocker or not. You will not have that issue. You'll be able to work freely. This defense mechanism is uniquely to us as far as we try to manage and investigate. We found it critical to put a defense mechanism so our customer will not fail from it. We think that it's vital that every other customers will do precisely the same. Microsoft has a sort of a protective measure against the wrong patches, for example, that were, let's say 50% of the cases. If a major patch by Microsoft causes it, the system can sometimes revert the patch completely, but it's only being done in the major patches. We are doing it to everything related to us, everything that goes to us. We're giving our customer the best of space that our defense system will not strike them back and will always keep them secure. Einstein, the great one, has said we cannot solve problems with the same thinking we used when we created them. And that's precisely the issue here. The issue was created because of methodical QA, methodical studying, and we try to fix it by QA. And since the problem does not rely on the QA, it relates on everything else, we need to do it in a completely different way. We are doing it. Everything about Cyber 2.0 is innovative, is different, is designed to give a better defense in a different way, and we are doing it in a way that no other system is currently doing it, from our chaos-based defense to our vortexes, and even to the smaller thing like this protective measure that can protect your entire network in case of someone patch from Microsoft, an Intel update, someone has done something with a different defense mechanism that collides with us, we will make sure that if you are with us, it will not happen to you. And we also give you our defense. Another thing too important, if such a thing will happen when Cyber 2.0 is on your premise, your defense will not vary. It will still stay. It's true that the agent will disable the affected driver automatically, but it will automatically it will notify the server, and the server will put it in a mode we call the isolation, making sure that it will be protected by the other computer inside your network, and malicious software will still not be able to affect it. The only one that will be able to change and manipulate it is you. In addition, the system will automatically disable any attempts by CNC, even if the driver are disabled, by a different mechanism. We have multiple layers, so even if someone will try to take advantage of such a scenario and implement something that bypass our defenses, CNC toward the network, command and control, the EDR, everything will still work, but in a different pattern. So we will remove one pattern of defense and we'll activate another that does not cause that outage. It is done automatically, no need on anything done on your part. And so even if we are down because of a blue screen, a repeatable blue screen, the system will revive itself and make sure that you are still defended and you can fix everything that caused the issue, while around you, everything will fail. Furthermore, we have developed what we call the Vortex device, designed basically for OT, IoT, and IT environment. The Vortex device is an independent device, simpler like a black box that's installed in front of the firewall that combined with the agents can give you a defense that will never wither. Even if the system will fail completely for some reason or the other, if you have got a Vortex installed on your premise, whether it is OT, IoT, or IT, we will still cut the attacker any attempt, because the Vortex can work solely and still give you the best defense possible once the system is down. The Vortex cannot go down because it is not subject to updates, changes. It's a black box. We are the only one that controls it, and it can only be controlled from our server. No one else can touch it. Of course, on on-premise server, the on-premise server controls the Vortex. Let's speak a bit about the Vortex. As I said, the Vortex is a hardware device that can be implemented in front of the firewall. It's a bridge, completely transparent, doesn't need to change anything in your own infrastructure. Without the need of changing everything or anything, it works in conjunction with Cyber 2.0 defense mechanism. No installation, no changing of the protection device, no changes in the firewall or switches. It's an add-on to Cyber 2.0 device and defense mechanism. And as I said, even when your defenses are down, the Vortex keep maintaining a defense, adding a layer of defense to your firewall based on our chaos system automatically. And since it does not need a software update, it can work in closed environment, protecting IT and OT with the same amount of efficiency because of the chaos mechanism. In order to understand a bit about it, I want to tell you how the chaos mechanism works. So we'll have a site why it is so effective with the Vortex and where the Vortex stays. Basically, what we are doing, we are using chaos-based algorithm, two drivers in the kernel that work in correlation with each other, and then communicate with the Vortex when they try to move outside for the internet. Every port is being scrambled outside if you are on a legitimate computer and a legitimate software, and this scrambles on the other side by the same chaos algorithm. The computer are not aware that they have changed something in between. When a malicious unknown or unwanted software try to do the same, even if it managed to achieve full domain admin privileges, I won't touch it, I won't change it. The drivers that are based can either work on layer 3, layer 4, and layer 7. So when one driver falters because of a crash, the other takes its place and make sure that the system will still give you the same protection. And when that untouched driver gets to the other computer, it simply scrambles and gets closed by the other side seamlessly. The vortex acts as an agent for the firewall and OT devices in precisely the same manner. And it can work solely alone, identifying the package that are not supposed to go if everything fails. But since only one driver will fail, you will always have full visibility of the system. So using Cyber 2.0, make sure that what happened with CrowdStrike cannot happen to our customer, something that we implemented a long time ago because such a thing can happen, something that we think and believe that everyone should implement in their system because it will happen again to everyone at one point or the other. And in case of the system fails because of such a patch or an update, whether it is their fault or the other side, our system will still give you full defense because other drivers will keep defending it. And if you've got a vortex deployed, it will keep and make sure that the hackers won't be able to communicate, send information outside from your organization. In order to accommodate for that, to know precisely what has happened during the blue screen or during after the second and the third driver that work in layer 7, map everything that goes inside your computers. So the moment that a blue screen happens, the logs file, let's say that have not been sent because of the blue screen, once the agent reloads, will send the log file to be analyzed on the main server. And you will know precisely what the last thing that happened that caused that blue screen, whether it is Cyber 2.0 related or whether it is something completely different. Even if the blue screen has no correlation with Cyber 2.0, you will know what is the last thing that this computer has sent and witnessed because the logs will be stored at the other side. A lot of time hackers deliberately cause a blue screen in order to crash your system. You will know what caused it because of Cyber 2.0 and easily mitigated because the logs will be sent and stored on our server and not on the computer. Furthermore, this thing allows you to mitigate multiple types of attack and identify everything according to the hashes. And in one side, know what happened, and on the other side, mitigate every possible chain or unknown file from mitigating and propagating inside your net. That concludes our technical webinar about what has happened with the CrowdStrike. The issue was simple. It was a human mistake that caused an outage that caused the major and largest crashes in history. And the result of it will be known for days to come. We are still counting it. The company are still inside of it. If you have any question, this is the time.
Thank you very
If
much.
not, then I will move the speaker right back to Snare. Snare, it's up to you. It's you.
Thank you very much, Erez. That was very, very interesting. Too short. You have to work on it. But if you have any questions, we'll be happy to answer them. Otherwise, I would love to bid you farewell. Godspeed. And if you need anything, we'll be happy to assist you. All right, then that's a wrap. Thank you so much for everything, everyone. It's been great seeing everyone. Take care of yourself. If you need anything, we're here to assist you in any way we can.
Thank you.
Thank you.